Okay, we're live now.
Cool.
Okay. You guys want to just start the quiz?
Yeah,
Yeah.
let's start the quiz.
I'm opening it up on VMware because we're going to need SPSS.
Okay.
Most likely, yeah. Okay. So, Cody, I figured out how to do the one question that we were having struggles with.
Oh, really?
Yeah, so on the applet, you're supposed to highlight the upper part of the curve and put in the probability 0.0403. And to find the p-value, you highlight both ends because it is a two-tailed test, and that gives you the p-value.
Oh.
You
So
basically
basically,
just multiply by 2.
yeah, you basically multiply by 2.
Oh. Okay.
Alright.
Okay. So, when requirements must be checked when conducting, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark that all apply.
Is it all? Wait, is it all?
Here, give me a second.
The mean. Well, the mean doesn't have to be greater than 0. I think it's all of them but the third one.
So
I'm not quite sure about that one.
it says in the textbook, a simple random sample is drawn from 8 populations, and X bar is normally distributed for each group.
Does it say mule is less than 0?
I think the mean, that's the mean, right?
Mule?
Is that?
Yeah, that's the real, or not the sample population. It's basically the real population's mean,
I'm pretty sure that can be less than 0.
or greater than 0. Sorry, I meant to say greater than 0.
It also says, remember, the second requirement will be satisfied if the original populations are normally distributed or sample sizes are large. So I think the last one has to be the same. I think it's just the first two.
Well, yeah, maybe they don't have to be the same.
So you think it's just the first two rather than the last two?
Yeah, it doesn't say anything about the second 2.
Yeah.
Because if you're just comparing means, then you can have any variations of sample sizes for each group.
The test is okay. Let's continue. The test statistic for a hypothesis comparing two means with independent variables is what?
The Still t-score? I don't remember the F statistic at all.
Is that right? The t-score? Here, let me see.
Yeah. I'm sure it's the t-score.
Yeah, I don't remember them saying anything about an F statistic.
In the previous reading, okay. One example of paired data is proposed t-scores.
It's number 5 is B.
B?
Yeah.
Knowing which subjects will be in group 1 tells you nothing about Yeah, that's pretty much.
So I'm gonna go and open this file. Hmm. Dun, 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 dun. Dude, we got our next exam next week.
I'm not like.
Pretty sure.
That sucks.
Yeah.
Do you know how to find the degrees of freedom
Just
on
end
SBS?
one.
Thank you.
I just tell you what they are. You just do
Yeah.
it, and so it's 39.
Are you sure about that?
Yeah, because the degrees of freedom is just the sample size minus 1.
Oh yeah, that's right. What's the sample size? Does it specify?
It's on the SPSS app.
Oh.
So what is the sample standard deviation for Rexburg?
So I just do like the normal. Because this isn't comparing anything, is it? So I opened it up and there's only one column of data.
It only gives you one column?
Yeah.
Are you serious?
Yeah.
Okay, so. Oh, that's why. Okay, what you need to do is you go to analyze, compare means, independent sample t-test.
Let's see. Sorry, it's slow.
No, you're fine.
Independent. Gotcha.
What is
Then
it?
what?
What does the screen pop up to?
Then it has those two boxes. On the left one it says Dennis, Bill, and City. And then I can move it over to the test variable.
Does the one say Rexburg or something?
It says City, it doesn't say Rexburg. There's the grouping variable.
I'm guessing it is the city.
What do I do with it?
What does it say? City and what's the other one?
Dentist Bill. So
Yeah, it's the city. I'm guessing it's the city.
Do what with it?
Yeah, go with the city.
And do what with it? Put it in the test variable or the grouping variable?
Yeah. Just say, okay, let's see. Okay, move the variable containing your data values into test variables box. In this case, this blah, 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 blah. Move the variables. This tells the group data. Okay, wait. Move the variable that tells to which group the data belongs into the group. I'm guessing move the other one into the group.
Which one's the other one? I would say grouping variables would be city, and test variable would be Dennisville.
Well, it wouldn't be the one. Test variable is one you want to find more information about, though.
Yeah, it has to be, because I tried to do it the other way and it still won't let me.
Okay, do it whatever way you need to do it.
Let's see. Add new name. What? Mine looks different than the one in the textbook. understand.
What do you understand?
Like it, because in the textbook it shows. So you go to transform automatic recode. Oh, I went the wrong thing. Transform. Okay, here we go. So no. Uh-oh. Okay, now what? The grouping variable into the box. So the city into the box. Oh. Oh. Okay. So what happens is on SPSS, let's say there's 20 variables. So in column 1 there's 20 different variables. In column 2, the first, or not 20, there's 40 different variables. And in column 2, it tells you the group that they're in. So 1 through 20 is going to be Rexburg. Then 21 through 40 is going to be Idaho Falls. And so what you do is you go to transform and then automatic recode, and then it brings up that box, and then you put the second column in the grouping column, which is the city name, into that, and then you do the automatic rename, and then anytime it's Idaho Falls, it'll just call it a 1, and anytime it's Rexburg, it'll call it a 2. So it's a different. So it groups it by number rather than by city because it can't recognize city in the app.
Okay, so did you do that already?
Yeah, I just did that.
Okay. And so we're trying to find the standard deviation for Rexburg. Yeah. In order to do that, we must do the analyze, compare means, independent samples means.
Okay. So now.
And you specify.
Compare means. Which one was it?
Independent.
Sample t-test?
Yeah. And you use specified values, either 1 or 2.
It won't let me press OK.
Are you having a problem with?
They just won't let me press OK.
What screen are you at?
Independent sample t-test.
Okay. Okay, it says move or did you already move the variables?
Yeah, I moved them both over.
You move them both over? Like to the group variable and the. So move the variable containing the data values into the test variables box. In this case, this would be the city or whatever. Move the variable which tells which group data belongs into. And it says move the variable that tells which group the data belongs into. Move that to the group variable box.
Yeah.
This will be it will be coded group code variable.
Oh, define groups. What am I doing?
Are you at the define groups screen?
Click on define groups. Next to group 1, what does it say? Type 1.
Yeah. And then on group 2, you type 2.
Then just press continue.
Yeah.
Okay.
And
Now
then it
press
should
OK.
show. Yeah, then press OK. And it should show up a screen that says independent samples test.
Yep. Okay. Degrees of freedom is. So we're looking at the second. Oh, okay.
What's the degrees of freedom?
Let me see. So the degrees of freedom is 37.996.
37.996. 37.996. That's the answer. So I think that would be the answer for number 6.
Yeah. It'll be different. Now, let me write down how I did all this.
6? Wait, why is the degrees of freedom different?
I don't know why it's different, but that's how I did it for this independent one. Did you hear how we found all that?
Yeah, just you separated the groups, right?
Yeah.
So basically the most important thing is you have to be able to separate the groups even though they're in one column.
Yeah. You got to put them in a number so SPSS can look at the different numbers rather than words.
Okay, and then find the standard deviation for Rexburg. What does that box say about whatever group you put Rexburg as?
Standard deviation. Let me see. For Rexburg, you say?
Yeah.
206.637.
206.3 what?
206.637.
637.
So what's the T value?
Yes.
What's the text?
Negative negative 0.434.
What's the P value?
In this case, you would wait.
Yeah, is this 2 tailed or 1 tailed?
That's what I'm trying to figure out. It looks like you would have to divide it by 2.
It's one-tailed.
So it's 0.333.
0.333. You already divided it?
Yeah.
Okay. Well, we're gonna figure it out.
Failed to reject.
So if it's greater than 0.05, we fail to reject. Or no, wait. It's 0.10. Sorry. If it's greater than 0.10.
Is that the number they give us?
Yeah.
Yeah. Then you fail to reject. So number 11, we have insufficient evidence.
Wait. So suppose instead you had used the alternate hypothesis as equal, so it would be two-tailed.
Yeah.
So you wouldn't change it.
Yeah, so you still fail to reject. So you still say we have insufficient evidence. But they're different or the same?
They're different. Because the null hypothesis is that they're the same.
Okay.
So we don't have enough evidence that the Dennis bills between the two cities are different.
We have insufficient evidence.
Yeah, that they're different. So B.
Yeah, that's right.
It would be B.
Yeah.
Okay, let me open up the second one.
Okay, this data represents the number of times freshman students from Utah and Colorado cook their own dinner a month. Let's mu1 represent the mean number. You suspect freshmen from dinner. What is the appropriate alternative hypothesis? You suspect freshmen from Utah cook for themselves a different number of times than freshmen from. Would it be not equal?
Hang on, I'm not looking at it yet. I'm writing down to make sure I know how to do the other thing.
Cody, what do you think?
Hold on. So it's not equal
That's what I thought. That's why.
because it's a. So he believes that. So you suspect that freshmen from Utah cook dinner for themselves? Oh wait. Okay, I read that wrong. It would be not equal.
That's what I thought. That's why. It says different. It doesn't.
He says a different number of times. If he would have said like more or less,
Yeah.
so it's yeah.
And then we need that. We need SPSS to find the T score.
Okay, so I have to do everything I just did all over again, huh?
Pretty much, I think so.
One sec. Okay. Whoa. This is Colorado and Utah.
I really don't want to do this. Not so stoked about the quiz or the exam.
Not?
No.
Yeah.
Are you just changing the variables right now?
Yeah, I just did it. Now I'm doing the. I'm pulling it up.
The independent variable calculation.
Okay, what does it ask for first?
It's a T statistic. The test.
So it's negative 0.845.
Say it again.
Negative 0.845.
845. What's this asking for? 3. So 8 point. Negative 0.885.
No. Negative 0.845.
Yeah.
Yeah, you have to round it to 3 decimal places.
Yeah, so 845 would be the
Not
3.
0.0845. It's 0.845.
Oh, 845. Okay. I think I get 0. I don't know why.
What is the p-value? So this is
It's a
right?
It's a two-tail, so no dividing or timesing.
So it's 0.410.
4-1. Okay, say that again really slow.
0.410.
Point.
So we failed to reject.
Yeah. Oh, what? For mean of...
So
So you just calculate the...
Okay, so for this one you... Oh, darn it. Determine the 9 confidence intervals for... Give me a second, let me find this.
So is this a paired sample t-test?
yeah, I think so.
Here, give me a second, I might be able to find it.
I don't think I can do it because...
Okay, give me a second, I know how to... Okay, so... Do you get the upper and lower limits on the independent samples test?
Yes.
Okay, you got that?
Uh-huh.
Okay, so I'm looking at the SPSS instructions. So looking at the bottom row when it says equal variations, not assumed, we find the 95% confidence interval for the difference in the two means. So
What?
give me a second, let me just find this real quick and we might be able to find it. I'm just testing something right now. Point.
Uh-oh. What? I'm in a meeting. Give me like 10 minutes. So do you just find the normal margin of error using those bottom ones? So you do like upper minus lower divided by 2?
I'm trying to figure that one out right now.
You said something about it in the video.
So it would be the bottom one where it says equal variations not assumed. So do you see what I'm saying?
Yeah, yeah.
So it's not the upper one. One
So I've only
on
been
top.
using the bottom one for all of them.
It's the bottom one.
Okay, so then I just do upper minus lower divided by 2?
No. Let me just make sure I'm doing this right, because I don't want to be saying something that I don't know. Two means when dependent variables simplest way.
You didn't bring the dog up. No, get him out of here. What are you doing? Get out of here. I don't want a dog in my room. I'll be done later. Sorry about that.
No, you're fine. Okay, so it's just the bottom ones. So
Yeah.
when you say the 95 confidence interval of
Oh.
differences, it's, you know how there's two, one on top and one on bottom. So it's only the bottom ones.
Yeah, I definitely know it's only the bottom ones. So I'm just making sure that I find the margin of error the same way that we've always found it. You just do upper minus lower divided by 2. I'm pretty sure that's what you do, so I'm just going to do it.
Oh, you're right. That's what I'm wondering.
Yeah, because he said in the video you definitely just do the bottom one, so I know it's the bottom one.
Okay, yeah, just divide it by 2. Let's see what you got.
So I get 3.671.
3.671?
Yeah.
Okay. What's the lower, sorry.
The lower is negative 5.137.
Wait, was that the answer for 16?
Yeah.
What was it?
3.671.
Okay.
Okay, so negative 5.317
No, negative 5.137.
and 137. What was the upper limit?
The upper is 2.204.
Okay, the moment of truth.
So there is a difference then. Or no, there isn't a difference. Because 0 is contained in that.
Yeah, oh, I see what you're saying. So there is a difference.
Yeah. No,
Yeah.
there's not. We can't say that there is because 0 is contained in that interval.
What are you guys looking at?
I thought it was the opposite. If it's not contained, then there's
Yeah,
not.
if it's not contained in it, then we can say there is a difference.
Oh, am I thinking of it backwards? Okay.
What do you guys?
That's not a question on the quiz. That's just.
It's not, but
Okay, so what are you guys looking at exactly?
so like when you look at the lower bound and upper bound, like our
Okay.
null hypothesis was that there is no difference. And so the null hypothesis is that mean 1 equals mean 2, you know? When
But
you
there is a
find an
difference.
interval, what?
But there is a difference, right?
Oh, yeah, you're
There's
right.
not.
So 0.
Because 0 is within negative, it's between negative 5 and 2. We're 95% confident that the true interval is between negative 5 and 2, roughly, you know? And so, because 0 is within that interval, our mean could be 0. So we can't say that there's definitely a difference because 0's within that 95% confidence interval.
Okay, so state that again so I can like absorb this.
So because negative 5 and 2 has 0 within it, you know, we say that there's no difference. But if it was negative 5 to negative 2, we would say there is a difference because 0 is not contained in that 95% confidence interval.
So whenever 0 is contained, there is no difference.
Yeah.
Yeah.
Huh. Where does that explain that? Is that explain that in Chuck
He
lesson?
it in the last lesson.
Yeah, he did it in the video.
Okay. I'll have to look over that again.
Did someone submit this?
Okay, did someone submit already or?
I haven't yet. I can do it if you want.
Okay.
This one's just really slow since I have VMware open. Got 100.
You got 100?
Yep.
Woohoo! I thought we were gonna get like some of them wrong.
Feels good not to.
We rock this, dude.
Yeah. Now hopefully we
Boy.
can remember all this for the exam.
So we get to the exam. Yeah, I don't think I'm gonna do well in this exam though.
Really?
I don't think I will.
I feel like I prepared better for this one than the last one.
Yeah, I think you prepared pretty well too.
Yay, 100.
Okay, guys. Oh, go ahead.
I just want an A in this class. If I don't get an A, like, this class isn't very hard, so I'll slap myself.
I think the hard part is like we have other things that are going on in our lives that we just like have a hard time doing the homework and such.
Yeah. Alright, well, I'm gonna go eat.
Okay, you guys have a good one. I'll just post.
See you guys later.
Yeah, I'll just post the video on the thing.
And I'm pretty sure we have our exam next week, so I think we'll have another meeting on Tuesday. And
Yeah, we'll probably have a meeting on Thursday too.
yeah, I don't
That's
know
how it
when.
was last week. So I mean, last week we had exams. So
And we still met both days, didn't we?
yeah. And we can talk over the exam, I think, can't we? After it's been graded.
Yeah.
Yeah.
That's cool.
So we'll probably have a final exam. I don't even know. Oh, I would hate that.
Oh, that was. Let's see. Yeah.
I know we have. Do we?
Well, it says for lesson 15, which is next week, we do the review and take the Unit 2 exam. So the review will probably just be the review for the whole unit,
Yeah.
and then the exam will be that weekend, I guess.
I assume. Yeah.
All right. Cool. Well, good luck, y'all.
You guys have a good weekend. Okay. See you
Y'all
next
too.
week.
See
You
ya.
guys later.